Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about polarization of electromagnetic waves. How the questions will come based on this topic, polarization of electromagnetic waves. This polarization of electromagnetic waves is very important area. Why it is very important area means the electromagnetic waves can polarize in the linear medium or any material you have to take. So there is a polarization can happen, whether it may be electrical polarization, whether it may be magnetical polarization, whatever it may be. So that atom should be oriented in such a direction of applied external applied external field, whatever based on the field, that should be oriented. Once we have to see in this question, in GATE 2019 this question was asked based on the polarization of electromagnetic waves. First you have to see here the electric field of an electromagnetic wave is the electric field of an electromagnetic wave is E is equal to 3 sin kz minus omega t into x cap plus 4 cos kz minus omega t into y cap. What is your electric field? Once you have to see here. So your electric field, they are giving your electric field E is equal to, your electric field E is equal to 3 sin kz minus omega t into x cap kz minus omega t into x cap plus 4 cos kz minus omega t into y cap kz minus omega t into y cap. First what we need to know, so what is that? So question once again you have to see the electric field of an electromagnetic wave E is equal to 3 sin kz minus omega t into x cap plus 4 cos kz minus omega t into y cap. The wave is they are giving. So whether it may be linearly polarized, elliptically polarized. Based on the question itself only, this is EOX, this one is we have to take it as a EOY. EOX is not equal to EOY. EOX is not equal to EOY means such type of polarization we call it as a elliptical polarization. Which polarization it is? Elliptical polarization. Therefore it is not a linear polarization equation, it is not a linear polarization equation. Now we need to observe the elliptical polarizations options. Two options are appearing. One is elliptically polarized in clockwise direction, one is elliptically polarized in counterclockwise direction. So these two options we are. Which option we have to choose? Among these two options we need to do this procedure. What is the procedure? Once you have to take at kz is equal to 0, at kz is equal to 0, at kz is equal to 0, your expression can become E is equal to 3 minus 3 sin omega t minus 3 sin omega t into x cap plus 4 cos omega t into y cap, because why I have to write? So sin of minus theta is equal to minus sin theta, cos of minus theta is equal to cos theta we have to write. Here Ex component I am writing, Ex is equal to minus 3 sin omega t into x cap, Ey is equal to 4 cos omega t into y cap, 4 cos omega t into y cap you have to use. Now you apply omega t is equal to, first you have to take omega t is equal to 0 you have to take. If omega t is equal to 0, so your E value, what is going to happen, your E value once you have to see, sin 0 is equal to 0, cos 0 is equal to 1, that is 4 y cap you have to get, that is the EY, 4 y cap. When omega t is equal to 5 by 2, you have to take 90 degrees, you able to consider. So what is going to happen, your E? So sin 90 is equal to 1, cos 90 is equal to 0. This is minus 3x cap you are getting. So to analysis for a counter or clockwise direction, these things are enough. You have to take it as a xy plane you have to consider. Under the xy plane, omega is equal to 0. So then what is that here? You have to take it as a your y component is there, that is 4 y cap, correct. So next if omega t is this electric field is at 4 y cap, when omega t is equal to 5 by 2, your electric field is minus 3x cap. How it is coming? So it is coming in which direction it is coming? It is a counterclockwise direction, anti-clockwise or counterclockwise direction. Which direction is taking as a counterclockwise direction, correct? So that's why is this elliptical polarization, it is coming as a elliptical polarization, it will come. In which direction it is going to take? It is going to take it as a counterclockwise direction. That's why what is your option? Your option is electrically polarized in counterclockwise direction when seen traveling towards the observer, right? This option is correct, this option is wrong. So based on your assumption, you have to solve this one. So already I am informing you, we started the CSIR and GATE batch in pure online mode only, or JL physics content, DL physics content is available. So entire the portion is not available. So 2 papers are finished. So the 3rd paper we are going to be finished within the 20 days I have to finish, right? So 3 papers are available right now. If you want to buy the individual paper, you have to buy. Otherwise, if you have to take the long term goal, so to prepare also it will take 6 months. So that's why you have to take right now. Within the 6-7 months I have to wind up almost 90% of the syllabus I should wind up. Clear? You see our CSIR and GATE physics course will appear like this. You have to see our JL and DL physics course will be appear like this. So we finished the mathematical methods of physics. Entire the core and advanced part of the CSIR is available now. So classical mechanics, if you want to take, you have to take this classical mechanics entire paper is available. Electromagnetic theory, this electromagnetic theory also is available. So this one is now live plus recorded classes are going on in the electromagnetic theory classes. If you really likes my teaching, if you really sync my teaching style to you, you're able to understand clearly, then you have to choose this app. This app will give you a good courage in the physics subject. Thank you so much. So please share and subscribe our YouTube channel. Like these videos, I will upload whatever the entire the CSIR portion I have to teach in our YouTube channel. Thank you so much.